All right, so we're going to get into heat pumps. We're probably not going to make it all the way through heat pumps. I want to at least get into electric heat. I guess first things first. So what is one of the first complaints that we get as soon as we get into heating season? People start turning the heat on. Burning smell. Good old burning smell. So that's why early in the season, and I guess for other parts of the country, they're already well into the heating season, but for us, we're just now getting started. As soon as it starts to get into the 40s at night, in some cases, kind of mid-30s, that's when electric heat's going to come on for the first time. Same thing is true with furnaces too. First time the furnace starts, people are going to get that burning smell. It's going to happen either way, but what can we do to help prevent that for our clients? Go ahead, Elliot.
Burn them off during maintenance.
Burn them off during maintenances, right? And so a lot of times, and we have to make sure that when we're following protocols or checklists or processes that we don't throw the baby out with the bathwater, because sometimes you're going to be given a process or a procedure that's just is too much. Like it doesn't make sense. I'll give you an example. Testing defrost every time you do a maintenance. Okay. And in some markets that actually makes a lot of sense, because in some markets you have, you may have a cold snap in the spring or in the fall, and you may have a really cold winter where you absolutely need defrost. But for Florida, it's probably once every 5 years that defrost even comes in to be a factor, where you have cold enough periods of time that a coil stays frozen. Usually, even if it does frost over at night, by the time the day comes, it's going to defrost. It's not going to be a big deal. So for us to spend that additional time to test defrost every time we go do a maintenance just doesn't make sense. It just isn't practical. And I don't know of anybody who does it other than maybe like one technician, here or there. Now that doesn't mean that you shouldn't know how to test defrost, because it's still going to come in really handy. But the times that you're going to be testing defrost is primarily that 1 in 1,000 where you show up on a really cold day and you observe ice all over the coil, right? So that's just one example in heat pumps. But what often happens is we'll say, hey, you have to test the heat strips, okay? So how do we test the heat strips? Elliot can't be the one to keep talking, so somebody else. How do you test the heat strips?
Crank up the thermostat until the heat strips come on.
Crank up the thermostat till the heat strips come on, right? Well, what's the problem with that?
Sometimes it don't come on.
Sometimes it's going to take a while for it to come on, right? Because you have, especially in modern thermostats, you have an algorithm. In a lot of cases, you have a lockout nowadays where the outdoor temperature is going to lock out the heat strips. So there's all these things you have to deal with just to try to get the stupid heat strips to come on. And here's the thing about heat strips. We don't really want them to come on. We would be very happy if a winter went by where somebody didn't have to use their heat strips at all. Why is that?
They're expensive.
They're expensive, right? They're super expensive to operate. In fact, one of the number one strategies to reduce people's power consumption in the winter is to find novel ways of keeping them from running their heat strips. The number one way to keep people from running their heat strips is by not having big temperature swings, right? So this idea of temperature offset, that's the term manufacturers use, thermostat manufacturers, which means that when you're not in the house, you let the temperature go up or go down, and then when the house is going to be reoccupied, then you bring it back to temperature. That works pretty good in cooling season. In some markets, here it doesn't even work great because of humidity. But in some markets, that can be a real savings. But on the heating side, it's not a savings. It's absolutely not a savings if allowing the temperature to drift down in the home when it's cold, and then when you turn it back on, you've got to turn the heat strips on in order to get it back up, because heat strips are significantly more costly to operate than heat pumps, especially as heat pumps are becoming more and more efficient, right? So that the gap is widening even more and more. So we don't want heat strips to run that much. Testing heat strips can be tricky. So how do I really want you, practically speaking, to test your heat strips? What's the practical way of doing that?
How the customer do it? At the thermostat?
That would be, again, the best way.
RW.
You're going to jump RW, right? That's going to be one of the easiest ways to do it. Just to confirm that they do come on and that they go back off. Go ahead.
So a lot of thermostats these days, actually, you can toggle just the aux heat. Even basic Honeywells have that.
And there you go. And that's the other really good way of doing it, and probably the best way, honestly, is to just use your installer setup or your service test out within the installer menu. in order to do that. And that's even true of things like the Infinity controller. That's really easy. In fact, when you're doing a maintenance on a system, on a communicating system like the Infinity, going into that service test out mode and testing all your modes that way is going to be by far the easiest way of doing it. And that is better than jumping R to W. But I want to be really practical here. What we don't do is say, oh, well, the way to do it is so hard and so time consuming that I'm not going to do it at all. This is the point I'm getting to here. It may sound like I'm justifying bad testing practices. What I'm saying instead is that you don't give up the good because you can't do the perfect, or because the perfect is too time consuming, or because you don't know how to do the perfect. So making sure that you run the heat, especially in the fall, is really important, and not just the heat pump heat, but also the electric heat. Make sure that it's working, right? There's not some significant failure. Odors are really, really common. Customers are still going to be concerned, and so whenever a client is concerned about something, you cannot be dismissive about their concerns. If you're dismissive, overly dismissive, then they're going to think that you're just trying to bury something or whatever. And so you want to talk to them as though what they're saying is a valid concern, but just communicate that, yeah, all heating equipment, the first time or two that it operates, there is going to be a slight odor. If it is very extreme, and especially if it's a maintenance contract customer or system that we recently installed, then we should probably still go take a look. One of the worst things that I've seen, and this was a house where kind of ignored what the customer was saying, and eventually we went out to find that the installation instructions were sitting on top of the heat strips. Or other things. I mean, I found lots of different things on top of heat strips, and they can be pretty stinky. So, or mastic got on it, or there's all kinds of stuff that can happen that will continue to be a problem, and we need to be willing to address that. Now, if you did want to see what was going on with heat strips, what would be the easiest way to find out?
Pull the blower.
You could pull the blower. That would be one way. Yep. The other would be to pull the heat strips, right? Depending on the brand, and Carrier, that's both pretty easy. To get either out is pretty simple. I would probably just take the two screws out and just pop the heat strips out. But either way,
Was with you,
Pull it all out.
It depends,
You're
what
with
the,
him.
it depends what the access is. If you got a lotting type compartment behind, in front of the heat strips, then the blower can usually see what you need to see.
yep. And my point is that, like one of the worst cases that I ever had, I'm not going to tell the whole story because it's a long, boring story, but was in a bank where I tested the heat strips, and they hadn't run probably ever. And I don't know why fully, but they just hadn't. And it just started billowing white smoke into the store. So you do want to think about, when you are testing heat strips even, is there the possibility that these have never been tested? This is especially true in commercial applications, that sort of thing. And you also want to notify the client that you're about to do the heat test. So when you're there in the fall and you're going to burn off the heat strips, you want to tell them, hey, today I'm going to be running the heat. So you're going to probably get a slight burning odor while I'm doing that. It's nothing to be concerned about. The other thing that whenever we test heat strips, and this is especially true when you're doing installs, you always also need to make sure that they go back off again. That's really important. It's always an opportunity when you're testing them for you to forget and leave a jumper in or what kind of thing and leave it running in heat. And that is a really, really bad call to get a month later when they get their power bill. Now, the good news is that the system will dehumidify great. So that's good, because then you have reheat, and anyway, I won't get into that. Again, once you do test the heat strips, then you need to continue and do all the rest of your tests as well. One of the most important things, and just to back up quickly, how do you test heat strips? Like, what is the actual process for testing heat strips?
From the thermostat,
No, that's not, sorry. What I mean is like, what tool do you use to actually check heat strips? You use an amp clamp, right? Okay, you use an amp clamp. And where do you put the amp clamp?
On the wire.
You put the amp clamp on the wire going to the heat strips, right? Or the high voltage
Put
wire.
it on just the high voltage coming in.
There you go. And that's actually what I was wanting to get at, is that putting it on the high voltage coming in, you're still going to know whether or not your heat strips are running. And the reason is because heat strips draw a lot of current.
Go from 2 to 20 real quick.
Yeah, so exactly. So you have just your blower, heat strips come on, you could go from 2 amps to 22 amps, like Jessica just said, really quickly. So it's okay to test it on the main line coming in. And we're not looking for perfection here. A lot of guys get kind of silly about it. They're like, well, 5 kilowatt heater normally draws 20 amps, and this one's drawing 22 or 21, like whatever. Like, that's not the issue. That you're really not checking it to see the specific amp rating. I have never once ever replaced a heat strip because the amp rating it was giving me was wrong. Has anybody else ever done that? I'm sure it's possible. You have done it.
It was giving me half the amp reading it was supposed to. It was a 15 kW.
It was a 15 kW?
It was 15 or 20, something like that.
Okay.
It was giving me half of what it needed to.
Well, but it's because like only half of the strips were
Right,
working.
the other half was broken.
Oh, okay. I guess that makes sense. Yeah, right. Okay, fair enough. If you have I like these classes. If you have a 10 kilowatt heater, then you expect approximately 40 amps. If you have a 5 kilowatt heater, you expect approximately 20 amps. Now, this is another interesting thing. All right, so let's say, because I've done this, I've made this mistake. Let's say you show up to a job and you show up and you realize, oh, okay, this air handler only has the 30 or 35 amp breaker on it. The wire sizing is for a 5 kW, but darn it, I have a 10 kW heater with me. Have you ever considered just disconnecting half of that heater and only running 5K? See, maybe this is just an old school thing. And probably because of the whole like sticker reality nowadays, it used to be that, yeah, you didn't have stickers, you would just kind of write and so you could get away with that. I guess I'm just expressing you never want to do that, because what's going to happen is the next service tech's going to come out, he's going to see, oh, it's a 10 kilowatt heater. And, hey, half aren't working. Well, by golly, it's disconnected. And then they're going to connect it, and now you're going to overcurrent the circuit. So things like that, it's just, don't do goofy workarounds like that. And again, clearly I'm only talking to myself because some of you have even considered doing that. Sizing breakers and sizing wires is really important. You can never just replace a breaker with a bigger size without also considering what the wire sizing is. This is a simplified chart. So when you look at this, number 6 is 55 amps, and a lot of you will be like, well, yeah, but we have number 6 going to systems with 60 amp breakers all the time. This is for the lowest common denominator of wire. This is basically if your air handler is fed with Romex. And this is something you may not realize, but everybody knows what Romex is. Romex is the wire that's where they're put together with the jacket, the jacketing all in one. It's also known as NM, or non-metallic. That wire has a lower temperature rating than other types of wire. So when you have regular stranded wire that's in Carflex or Seal Tight, or any other type of wire other than NM, you're generally going to be able to have a higher ampacity, a higher amperage capacity on that wire. So when people say things like, well, a number 10 wire is 30 amps, that's if it's Romex, basically. There are other types that are also that, and I'm not going to go into all this, but we have an entire article and description, different types of wire and what their ratings are. The point being that for most of the types of conductors that are used for, say, a 10 kilowatt heater, you can actually do a number 6 wire, and that's the reason why. If any of you have ever thought about this, it's like, well, I'm putting a 60 amp breaker on it, how does that work? The other thing is that you size wires, conductors. This applies to both air handlers and condensers. You size the conductors by the MCA, okay, minimum circuit ampacity. So whatever that is, you have to size the wire to cover that, and you size the breaker by the maximum fuse size, maximum breaker size, or sometimes they call it MOCP. Those are two different things. We don't have to know anything fancy other than that. Now, when you see the MCA number, and say that MCA number is 32, and the question comes, well, can I use number 10 wire on that? It depends on the type of number 10 wire at that point. If it's Romex, no. If it's one of the other higher temperature capacities, then yes, 75 degrees Celsius, 90 degrees Celsius. Not covering, that's not what this class is about. All you have to do is just go back and reference the article on that, and there's whole charts from the NEC that covers all that.
But it's important to know that that's a thing, and
Correct.
that you can go figure that out
Yes,
when you need to.
you can find that answer, right? And generally it's not going to come up. Generally it's not going to matter. But when you have a 10 kilowatt heater and you look at it, it's like, well, my MCA is over 55, so can I use number 6 wire? That's when that starts to matter.
And when it matters because it's about not burning a house down.
Right, exactly. To quote whatever band that is about burning down the house, you don't want to do it. They make it sound like a good idea, but it's not a good idea. Jessica's laughing, nobody else is.
Because I'm old.
Right, we're old. Isn't it weird? All of a sudden you wake up and you're the old person in the room. You know what I mean?
Dre put that song on when for his first Braze experience inside the house.
Did you? Okay. It's good. I respect that. All right. So obviously, you can't undersize breakers, you can't oversize breakers when it comes to air handlers especially. Can you undersize a breaker on a condensing unit in some cases? This is not a trick question. Can you undersize? Yes, in some cases, you can go, and by undersize, I mean you can go below the max. Now, inspectors don't understand this, so we just go with the max because we don't want to argue with them. But you can actually do that in the case of condensers in some cases. You really can't do that with air handlers. And the reason is that the current that the electric heater draws is steady state. It doesn't have peaks, it doesn't have valleys, it's just 20 amps. When that 5 kilowatt heater's on, it's 20 amps. When that 10 kilowatt heater's on, it's 40 amps. And it's just that simple, and it runs steady state that much. Make sense? Mm-hmm. And so because of that, it's not like you have this starting current where you've got a little bit of flex there. It's like, okay, well, we have a little bit of buffer. It's just bam, it's on or it's not. And so when you run into a case where you have a heat pump and the inside breaker is tripping, really keep that in mind. It could be a missized breaker, but also like everything that goes into those heat strips, because they draw so much current, has to be really well connected. One of the stupider things that I've seen people do is they'll have like a wire burns up or they got to remake a connector or whatever, and they'll just use whatever size wire. Well, when you're talking about heat strips, it's just like the wires that go to your compressor, only worse, because there ain't a compressor out there that draws 20 amps steady state. They don't exist, right? Or not in residential. They're going to peak at times. Why did I just say that? That is true. You will get some, I guess, that are in that range, but older R22s, and then also if you get like you have like an inverter-driven system that's screaming in heat mode, you may get that, but you're not typically going to have that. So when you think about what wires you're going to run to, even to the relays or contactors that could power heat strips, you just got to think about that. You can't just pull anything off the truck and use it. Make sense? Cool. The final thing that I want to talk about, and I'm not necessarily going to go through this whole illustration here, but it's this concept of blower interlock. A lot of different manufacturers do blower interlock differently, and the concept is fairly simple. And the mistakes that people make are also fairly consistent. So blower interlock is just the idea that it makes sure that whenever your heat is on, your blower is on. And this goes back to a time when thermostats didn't give a G-call in heat. And in many cases, they're still set up not to. And so what they wanted to make sure of is that if you have a W-call that's bringing on your heat strips, your blower is automatically coming on. And again, different ways that this can be done, but one really common way that it's done is actually on the high voltage side through a relay. And the simplest thing to explain this is whenever we, and again, this is a whole class in itself, and Bert may go over this a little bit more next week, but whenever we wire up a relay, we often wire it up where we are used to putting power in on the 1 terminals. If you look at this picture up here, illustration number 2 shows you kind of how we typically wire up a relay, where we put power in on the 1 terminal and then we feed out to our loads on the opposite side of the relay. But when you're using a relay for interlock, you actually imagine turning the relay upside down, basically. That's the easiest way to think about it. And if there's nothing else that you remember from this, because you're like, I have no idea what you're talking about, just remember that when it's time to wire up a blower and heat strip interlock, just turn the relay upside down and you actually wire in your power on the opposite side. So in this case, it would be in the 3 or the 6 is the side that it comes in. And without getting too involved here, the reason that is to ensure that it's not going to do the opposite effect. Because we do want the blower to come on anytime the heat strips are on, but do we want the heat strips to come on anytime the blower's on? No, we do not. And so if you wire it the other way, that can be an unintended consequence, and that is a very bad unintended consequence. And when this comes in is when you're replacing generally a factory relay with something like a 9340 truck stock relay. And a lot of people out there would say, well, why would you do that? You should never do that. You absolutely can do it. It's just a matter of understanding what the heck you're doing. A lot of factory relays can easily be replaced with aftermarket relays like a 9340. But you just got to know what the intent is. And the intent is for the electric heat, for the blower to be on anytime the electric heat is on, and the opposite to definitely not be true. So what is the final step you do if you've ever messed with the relays that do blower electric heat interlock? What's the last testing step you need to do?
You need to run the blower and make sure your heat strips are not running.
Absolutely. You need to run the blower and make sure that your heat strips aren't running. You need to make sure that they go on.
Blower comes on.
You need to make sure the blower comes on when the heat strips are on, right? So run it at heat, make sure the blower comes on. And then you need to put fan on only and make sure that your electric heat stays off. Make sense?
Yep.
Okay. Another thing that's just worth mentioning is you may still run into some more old school systems that have heat sequencers in them. Okay, and a heat sequencer, and I should have a picture up in the YouTube video. We'll put one up here. But a heat sequencer is a type of relay that's heat activated, and it automatically has a time delay in it. And so because of that, if you're ever working with a system that has a heat sequencer in it, some people call it a stack sequencer, you'll notice that there's a delay in both directions. There's a delay for the heat to come on, but there's also a delay for the heat to go off, because it has a little snap action disc, and it's not magnetically driven. So it's not like contacts that just open or close. There's a little disc in there that's actually being heated up, and then it eventually snaps, and then it kind of resets. So it kind of does this thing. And that takes a little bit. And so if you ever run into one like that, and you're like, these heat strips aren't going off, what the heck's going on? It's because it just takes a little bit to cool down before those return to the old position. And the opposite's also true. It can in some cases. It depends on the timings. And so you can actually look up that relay and figure out what the timings are for the different stages within that sequence.
So not a little bit like 3 minutes.
Not a little bit like 3 minutes, right. Not a little bit like half an hour later. These heat strips are still running. And again, the worst phrase that technicians will say is, I think that's normal. I think that's normal. You have to know if it's normal or not, and you have to make sure that it's right before you leave, right? And it's that impulse that we get to say, like, I don't have time to deal with this right now. But things like your electric heat staying on all the time, you definitely have time to deal with that, because that's a very expensive problem to run into. All right, so when it comes to electric heat, kind of top things, we do have to make sure that we test it on installs. We have to make sure that it goes on. We have to make sure that it goes off. When we do our fall PMs, we need to make sure that we operate those heat strips at very minimum. Even if it's just jumping it out, that's better than doing nothing, right? Same thing is true with gas furnaces too. I didn't mention this, but obviously we need to be operating that gas furnace. And we need to be doing all those test protocols that we just talked about. We're going to be doing a lot more gas furnace testing, a lot more gas furnace training as well. So whatever things you're used to doing right now on that front, we're going to be doing a lot more of. With electric heat, it cannot get more easy in terms of the technical aspect of it. It's very simple. You apply power, they heat up. But when in doubt, pull the blower out, pull the heat strips out, actually physically take a look at them, make sure that you burn them off. If it seems like too much, take a look. And then make sure that if you are doing any changes at all in the actual high voltage wiring, relays, connections, anything like that, that you ensure that you test this and make sure it's working properly. All right? Any questions about any of that? Anything else you'd like to add, Bert? I feel like I did kind of incomplete here.
Sure.
Go ahead.
Just that this is more of an older setup. With the blowers now pretty much all being X13, you can't interlock the high voltage and bring on the blower, and so you can use the relay on low voltage, that if W calls, then the blower calls.
Right.
And so you can do the same thing with low voltage. That would be a more common setup.
Today, yeah, correct.
And then the other setup is they're also just tapping straight into the speed of the blower with
Right.
white.
More and more, your 24-volt calls are just going straight to the blower. So
Yeah.
the blower is actually just looking at what's calling, and that's how it's operating. And again, we're in this kind of weird state where when you're a service tech, you're going to be seeing a lot of stuff like this still. But when you're installing the newer things that are coming out, all of this is pretty much going away. It's like talking about charging a system that has a fixed orifice and how you charge by superheat. Those are pretty much not all gone, but mostly gone at this point. And then it makes it a problem, though, and this is why it's still important to train, because the less you see it, the more likely you are to totally screw it up when you actually show up to do it. The same thing is true if you show up on an R22 system, forget to pay attention, and start adding 410A to it. And again, that happens more the less you actually see something. And so it's important to still have in your head. And the more things, and this is just a kind of a final tip here, the more things that you're expected to remember, the more likely it is that you just do that, it's probably fine thing. And what I'm saying is you don't have to remember everything. You don't have to remember how to do this. I can guarantee you, you're not going to remember how to wire up a 9340 for blower heat interlock. But we have this 9-panel. This is just half of it. Here's the rest of it. We have this 9-panel that shows all of this. And when you first look at this, even, it's going to be like, oh, my brain's melting, right? But you just got to go through the steps and read through it, and it will make sense then. All of this stuff exists. Okay, this is also one of the checklists that exists on the HVAC school lab. So everything that's a 9-panel that we do like this, where it's a square, also has a checklist on the app. And just, again, I'm not saying it doesn't have to be my app. If there's something else out there that shows you how to do the same thing, use that. But don't just say, oh, I remember there's something about this, but yeah, it's fine. Because again, those can be very, very costly things. So wire sizing is important, knowing when to go look at wire sizing, and also knowing when to stop and figure out what you're doing there. But testing is always the key thing, because even if you do screw it up, even if you do wire something wrong and you test and you're like, heat strips aren't going off, then you can easily find that, figure it out. So Elliot's getting a little too excited over here.
Use the 93 relay as a heat strip contactor.
There you go. Yes.
Yes. I did, and melted it.
Yes, that's right. I do remember this very conversation.
That this relay had some important job related to the heat strips. And so when I found a failed heat strip relay, one of my first on calls, I decided to put a 93 relay in there because that was so much smarter than using a contactor on my van. But they're rated for like 14 amps max.
Yep. In fact, that's one of the ways, if you've ever thought about this, like what makes a contactor different from a relay? Like, because they really kind of do the same thing. They have an electromagnetic coil, they pull contacts in and out. Generally speaking, a relay, at least in the residential world, is something that's 15 amps or lower contact rating. So that means that for compressors and heat strips, no bueno, you cannot use a relay for those. Relays are generally used for low voltage control, passing power for low voltage purposes, or for what we do, like a blower. That's pretty much all they're good for. Heat strips, compressors, you're going to melt them. So, yeah. And again, that's just paying attention to the current rating. And this is something that even things like using wire nuts, I'm just going to end here, but like just using wire nuts to put wires together, it's like, hey, I got a wire nut that the wires will fit. So we're good, right? Not necessarily. That wire nut has a rating. It has a current rating, and it also has a rating of how many wires can go under it. Same is true of every conductor. So I don't expect you to know all that stuff. None of us do. But you just have to stop and say, does this look right? Like, am I doing something that makes sense here? And it is going to be on the package, right? Now, again, you may not always have the package and all that, but that's just where it's best to stop and think about it. And especially as those currents increase. When you're working on, 10 kW, or even in other markets, 15, 20 kW heat, you got to really start thinking about those main connections that are coming into that appliance. Are they going to handle this? And that's why in many cases you end up going to separate circuits. You'll have one circuit that powers one set of 10 kW and another circuit that powers the second set. Just always thinking about that. Like wire size, connections, all of it, those all have ratings. You may have really good wire, but if the connections that it's coming into aren't rated for that additional current, then those connectors will melt. In fact, that was one of the things that I used to see a lot with heat strips back in the days. You'd go in and the wire nuts would just be all melted off, and it was often because sometimes they just didn't make a good connection, but in a lot of cases they were expecting too much of those wire nuts. Cool?
Good.
Awesome. Bert's going to be here next week. I'm on vacation, so it'll be a lot more fun. Thanks, everybody.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. Also, don't miss out on our free mobile applications available for both iPhone and Android. They're packed with handy tools and calculators to make your job even easier. And while you're at it, join our thriving Facebook group. We're all about community. For techs, by techs.